All right, guys, so we are going to work on calculations for rates of reaction lab. Please do not copy the same data here. I'm using fictional data. So here's the data table that you would have to fill up based on your dry lab data information, okay? So this is on page 17 of our lab manual, but I went ahead and printed out a copy of some fictional data that I'm going to be using for our calculations. This is different from what you will have for your semester. So make sure you do not copy these numbers. However, you can follow through with how I'm doing the math, and I'll show you where I find the formulas as well. Okay, so the first thing is, once you have your set of data ready, you can actually transfer it on here, or you can just keep it on here. I'm just going to keep it on here and probably start to do my calculations over here. The first thing that we have to calculate is actually going to be the molarity calculation. If you look at the calculated data pages, right here. So if you notice, it says we need to calculate molarity of acetone, molarity HCl, molarity iodine, and I guess the average reaction time. That would be basically, this is 104 and that's 99. I have to average that out and then put it right here. Okay, and then we'll worry about rates of reaction calculation after that. So I'm going to go ahead and work on molarity calculations here, and then we'll do the average time. But how in the world are we going to do molarity calculations? So if you take a look at the introduction page on rates of reaction lab, it actually tells you to calculate the concentration of each reactant. We have to use M1V1 equals M2V2. So for our case, for acetone, it says for acetone and reaction mixture 1, where 10 mils of 4 molar acetone is combined with 10 mils of iodine and 10 mils of water, 10 mils of HCl and 20 mils of water. So if you notice, this is the mixture that's going to be in your tables from the procedure. So take a look at that on page 12. Right here. Okay, so you see how my reaction mixture 1, I have 10 mils of 4 molar acetone, 10 mils of 1 molar HCl, 10 mils of 0.005 molar iodine, and I have 20 mils of water. If you notice, every single set, it adds up to 50. See that adds up to 50? The bottom here adds up to 50. That one adds up to 50. The fourth one also adds up to 50. So your total volume is going to be 50 milliliters. Okay, so that's one thing we'll be using to calculate. So because we need to calculate the first molarity of acetone, and from my, I'm actually going to do it on this page here on the bottom here. Okay, so let's move that up here, down here. Molarity of acetone. We'll do just for mixture 1. Okay, molarity of acetone for mixture 1. I know that my formula is M1V1 equals to M2V2. So what I'm going to do is my original molarity was 4. My original volume was 10. And my new molarity is what I'm trying to find. My new volume is going to be, it's going to be 50. Because the total was 50. Okay, you take 10 mils of acetone, you dump a bunch of stuff in there, and the total ends up being 50. So V2 is 50 right here. So if you notice, V2 will be 50 for pretty much all the calculations here. Every single molarity, the V2 will be 50. Okay, what the V1 and M1 will be, that depends on the table. So for all the acetones, M1, it will all be 4 because of this. Okay. Now, for all the acetones, the volume does change. 110, that's 20, that's 10 and 10. And then later on, if you have to do HCl, you would do 1 molar HCl for M1. And then V1 will be 10 here. And then obviously M2 is what you're looking for, and V2 would be 50. Okay, so the V2 for everybody will be 50. So I'm just going to finish this up here. So M2 over here is going to be 4 times 10 divided by 50. Okay, so I'm going to end up getting an answer of, in this case, 0.80. Okay, so that's my molarity of mixture 1 for acetone. Now, the next thing you could do is, if you notice, everybody's going to be in 50, right? Because all the totals are 50. So, I mean, we could write it all out. But if you take a look, see how trial 3, mixture 3 and 4, okay? They have the same exact volumes and molarity as trial 1, mixture reaction 1, because it's 10 diluted to 50 total, 10 diluted to 50 total, and the initial molarity is 4. So that means the molarity of acetone for mixture 1 is the same as mixture 3 and 4 if we keep the same concentrations for your lab. So you have to check to make sure your lab concentrations here are the same as well. So double check your tables to make sure you have the correct volumes that you're supposed to be using. Okay, so in this case, in my case, I end up having the same molarity for acetone for mixture 1, 3, and 4. So I'm going to go ahead and write that down because I don't have to redo that calculation, correct? Now, and then I notice trial 2, reaction mixture 2, my acetone is a little bit different, not too much different. It's actually just double it, right? So it's M1 of 4, V1 of 20, M2 is what we're looking for, and V2 is 50. So I'm going to go ahead and write that down. So we can do that too. Mixture 2. Molarity of acetone. So you have M1 V1 equals to M2 V2. So 4.0, 20 equals to M2 times 50. So what I need to do now to get M2 in this case, it would end up being 4 times 20 divided by 50, and that should give me 1.6. Right here. Okay, so I'm going to go ahead and fill that in and put 1.6 on mixture 2 on my chart. Where's my chart? Okay, I'm keeping 2 sig figs here for my molarity. So the next thing is I can do the molarity of HCl using the same formula, okay? So what I'm going to notice is molarity of HCl. So we'll do mixture 1. M1 V1 equals to M2 V2. So my M1 is, from my procedure, 1 molar of HCl. My V1 is 10. Okay, my total is still 50, so V2 is still 50. So 1.0 times V1, which is 10, equals to M2 times V2, which is 50. So, and then to get M2, you have to take 1 times 10 divided by 50. So the molarity of HCl ends up being 0.20 for mixture 1. Okay, so one common mistake is everyone just copies the molarity down from what you used in lab, just the stock solution. You can't copy those numbers down because we are diluting them, okay? So you'll have to put in that number. So this is 0.2. So basically you just go through the table and then you put in all the molarity values. Well, I guess I wrote the units. Okay, so if you notice, I see that for HCl, reaction mixture 2 and 4 is the same as reaction mixture 1. So I'm going to go ahead and write that down too. So 2 is 0.2, 4 is 0.2 also. And then for the third one, you'll have to calculate that because that's a little different. It's just double of it. When you calculate over the double, you probably get the molarity just double here. Okay, now I want to show you an example of iodine as well. So for iodine, we'll do reaction mixture 1. Molarity of iodine. What we're going to do is, again, M1 V1 equals to M2 V2, okay? And then my M1 would be right here. You see how it says 0.0050? I'll write that down, 0.0050. My V1, I'm going to use 10 mils. And then my M2 is what we're looking for. My V2, it ends up being 50. Again, remember that all our experiment on purpose, we make sure I went to 50 total. So my M2 calculation would be 0.0050 times 10 divided by 50. And that should give me an answer of, let's see, 1.00, well, 1.0 times 10 to the minus 3 molarity. So I like to write it in decimal places here just because I already had decimals up here. So I'm going to write that down. It goes 0.0010. Okay. And that's going to go in my table. So where's my table again? So my table has. Okay. And then another thing you notice is if you take a look at my chart, I don't know about your chart might be different. It's 10, 10, 10, and then 5. So that means these three are the same. And then that one's half of that. So it would be 0.00050. And then when you do the calculation, you see this one here, it was double. So when it's double, it'll be 0.4. Okay, so go ahead and calculate molarities. That way you will have to show your work. So I'm just showing you a few here. And then once you have that, all your molarities are set. That's how you would calculate your molarities. Now, the next step we want to do is we want to go ahead and calculate the average reaction time. So my reaction time for the first one, the average is going to be 104 plus 99 divided by 2. So let me do that on my calculator. 104 plus 99 divided by, okay, that the total is 203 and then divided by 2. I get 101.5. So I'm going to go ahead and write down 101.5 right here in seconds. Okay, so we have that. And then the next thing we want to do is average out the second trial. So my second trial was, okay, I'll show you right here. So it was 104.99 for my data, 49 and 52. So let's go ahead, 49 plus 52. The total is 101 divided by 2. And therefore my average reaction time will be 50.5 seconds. Okay, and then let's go to the next one. I have 48 plus 49. The total of that will be 97 divided by 2. My average would be 48.5 seconds. Okay, and then let's go to the next one. We have 51 seconds plus 48 seconds. That totals to 99 divided by 2. That equals to 49.5 seconds. So that's my average reaction time. So it should be pretty simple for you to do based on your data. Okay, now that we've gotten the molarities out of the way and the reaction times averaged out, we can actually go ahead and get the rates of reaction here. To get the rates of reaction, all you have to do is take the molarity of iodine divided by the time. So for this rate of reaction here, you take 0.0010 molarity divided by 101.5 seconds. Okay, so I'm going to go ahead and write the work down, I guess, on the side here. Okay, so rate mixture 1 is molarity iodine. Then divided by the average time. So it is going to be 0.0010 molarity over average time. I calculated it was to be 101.5 because you see how I got my average time here? So it's that over that, okay? I got 9.8522 10 to the minus 6. So we'll just keep, well, technically we're only keeping 2 here, but I like to write a little extra. So I'll write 9.85 on there, okay? Times 10 to the minus 6. Molarity per seconds. So per seconds can be write as divided by s or s to the minus 1. That's the same thing. Okay, so I'm gonna go ahead and write that down on here. 9.85 times 10 to the minus 6. And then you continue with the rest, okay? To get your rates, you take the molarity of iodine divided by this time. That goes here. Molarity of iodine divided by this time, that goes here. Molarity of iodine divided by this time, that goes here. So that's how you would get your rates, okay? So go ahead and finish that.